All right, everybody, welcome to day 6 of Quick Pass. This is the final lesson of new material. And this lesson really isn't new material. It's more just a more advanced way to look at the material you've learned in the past 5 lessons. So everything from the pre-course all the way up, all those techniques you've learned, and the data types and the collections, and the ways to loop over them, which we went over yesterday. All that's going to be used in this lesson and then also in the mini projects. So, so let me go ahead and start sharing my screen and we can get moving. Let me see here. Share. Okay, so here we're on lesson 6. Let me go ahead and make this a little smaller if I can. I don't know if I can. It's pretty zoomed in. And so yeah, we're going to explore multi-dimensional data collections, and we had a taste of that. Oh, you know what? I'm not sharing, am I? I forgot. All right, there it is. Okay. So we're going to explore those multi-dimensional data collections, and we touched on those yesterday when we looked at nested lists, but we're going to go a little further, go into another dimension and look at 3-dimensional lists. And that will tie into a little bit. I mean, you're going to get more introduction into it when you go into the cohort, when you get into like machine learning and learning about the features there, the tensors and everything else that are involved with that. Those are multi-dimensional lists, and that's what you're going to be mostly working with that. But we won't dive into those concepts in this course. But I can at least share a few resources. I think we have a couple at the bottom of the lesson. So without further ado, yeah, let's talk about lists. So like a review from the previous lessons, we have a list, right? And it's a collection, and it's a collection of values. So it can be a collection of really anything. It can be a collection of strings or numbers or a mix of strings and numbers. It can be a list of lists or dictionaries. We just know that lists are ordered and indexed, so you can access an item through its index, and it has a unique position that doesn't change unless the list itself is changed, and it's accessed with that bracket notation. And then of course, the counting with most computer languages, it starts at 0 when going forward, and it starts at -1 going backwards. And y'all remember that beautiful graphic I had in there. It showed the word Python and had the indexes on the top and the bottom showing forward and backward. So that's just a review on lists. And if we look here, I have my list, and I'm going to go to hit play and select my kernel, and that'd be Python 3.11. I have my list is 1, 2, 3, 4, 5. That's my list, and my list at the index of 0 would give me back a 1, and then my list at the index of -1 gives me this 5 right here. Okay. And then we talked about 2-dimensional lists a little bit. A 2-dimensional list is a list of lists. So it's like having rows and columns of data, kind of like a spreadsheet. And nested lists still use bracket notation, but you have to add more indexes to access single data points. Remember, if you access an index of the outer list, so the yellow brackets, right, that's actually named my matrix. If you want to access the first index and you do so with a bracket notation, you'll get back this whole list of 1, 2, 3. So a single bracket index will return a, let me hit play on this one real quick. There we go. See, I run my matrix -1, and that returns this item because that is the item at the -1 index. So because this is a 2-dimensional list, I need to go ahead and add another bracket index to get the index of a single data point inside of there. So if you take a look here, I have my 8 sitting right here. And how do I access that? I just add another bracket and add the index of where the 8 is inside this inner list right here. So 0, 1, 2. then we know that can be a 1. So if I want to access the 8, I would say my matrix at the index of 2, and then at the index of 1, when I'm drilling into that, the other, the single data items. So that's how you would access them in a multi-dimensional list. This was just two-dimensional, but lists in Python are mutable, so we can change values in place using the assignment operator and adding brackets as we increase dimensions. So here we can say, let's change the 5 to a 500. Well, we go back and look at my matrix. The 5 is smack in the middle. And we know if we're looking at the outer list, this is the 0, 1, 2. And then so I need to get to this one, so that I need to use a 1, and then 0, 1, 2. So I need to use 1, 1. So looking here, my matrix 1, 1. And now instead of just looking at it, I want to go ahead and reassign it, change that inner list in place. So I want to make it equal 500. And when I run that, now the 5 is a 500. And lastly, as you know, lists are iterable, so we can loop over them. And how do we loop over two-dimensional lists? I talked about this yesterday, but again, we can have, we make our for loop. And if you remember from yesterday, when we define a for loop, right? This is the keywords. This tells Python to start a loop. And then this is a temporary variable that gets assigned every time the loop iterates. So every time it runs, this gets reassigned to whatever the next item is in your collection. And my matrix is the collection. And so I first start this loop. So when Python runs this loop, it's gonna run this line first and say, okay, I'm gonna start iterating. So it's gonna grab the first row. And then the next line is another loop. And so now we're gonna make another temporary variable called item. And we want to iterate over the collection, which is a list, in that row, and get each item. And so if we run that, then you can see that I print the 1 first, the 2, 3, and then I go to the next row, print the 4, and then the recently changed 500, and then the 6, and then the last row, 7, 8, and 9. Any questions on that? Sure. So James asked, can you repeat the explanation of how the 1, 1 changes the 500? Sure. So again, remember, and maybe I should go ahead and print my matrix so we can kind of see it here. Not my list, matrix. There we go. Let's try and run it that way. Well, I guess I had it right here, but so if you remember, I'll just go back to this visual because this is better. So if you remember, there's the outer list. So you have my matrix, and that is one list. And if you want to access an item in that list, you use the bracket notation. So let's change this to a 1, right? And so if I ran that now, and I'll get rid of this comment, I'll just put it back whenever I'm done. When I run that, I'm grabbing the second row because I have, remember, the indexing starts at 0. So if I want to access a single row in my matrix, which is defined as these outer brackets, this is the first item in my matrix. So if I use a single bracket to access an index of my matrix, this whole row or this whole inner list is one item. And then this is another item, and then this is another item. So my matrix has 3 items in it. So let's do this. Let me show you how. So Lynn, so I want to give you the length of my matrix, right? So if I ran that, while it does have 9 total items in it, the problem is we have nested lists. And so if I ran this, I get back a 3 because there are 3 items in my matrix. And that is this whole object. Inside of my matrix, though, each item is its own list. So if I were to say the length of my matrix at the index of 0, I also get back a 3. So because there's 3 items in this sub list, that's, you see the pink brackets? There are 3 items here too. There's 3 items there, there's 3 items there, and there's 3 items there. Does that clear it up a little bit? And when I say row, what I'm meaning is when you look at this nested loop here, this word row is a word I'm defining. So I can make this word anything that I want to. So, you know, I like to use the word chicken as our term. As long as I define it here too, Python will run. So for chicken in my matrix, for item and chicken print item, it's going to run it because I'm defining this as a new variable. So I'm making a variable name. I choose row because that is, you know, the best word to define what that variable is.
So essentially there's 2 sets of 3. So there's 3 in each, and then there's 3 sets of 3.
Yeah, it's multi-dimensional. So you starting on the outer list, if you loop over that, each item in that loop is going to be an entire nested list. And then to get into the items in this list, you have to just add another bracket or another level in your looping. And so if I were, let's say I wanted to print out my matrix, but without using a loop. So I want to print out every single item in my matrix without printing a loop. I would do this. My matrix 0, 0. And then 3, 9. The 9 to the 8. Is that 8? That's 8. There you go, 9. 0, 0, 0, 1, 0, 2. And this is 1, 0, 1, 1. And then 1, 2. And then 1 and 2. 2, 2, 2. Let me, oh goodness. Is it, I always forget what key to push. Not that key. Which one is this key? There it is. Yep. Goodness. I don't like. How do I prevent the pop-ups in VS Code? They are very distracting. Okay, there we go. Now I can print it. And so doing that accomplishes the same thing as that loop. The loop right here. That's the same exact thing. That's what the loop is doing. The loop starts at the first index and then goes to inner loop and loops through those. So it goes 0. And then see how the outer loop say 0. So it's 0, 1, 2. And then that changes to a 1. And then 0, 1, 2. And then it changes to a 2 and 0, 1, 2. That's how I print everything in my matrix. Are you stuck on the word item?
I thought item means, like, when you look at the matrix, you've got a bracket 1, 2, 3, and then 1, 2, or 3 would be an item in that group, right?
Right. So yeah, item would be each item in that nested list. That's why I use the word item, but you can use any term you want. I mean, Python lets you define that as whatever you want. This loop's just going to iterate and just redefine whatever it sees in the list as a variable. And that's what it's doing. I'm going to pull up this and throw our matrix in there so we can see it a little better. I was a visual learner too, or I still am. So I love to see examples of stuff. So if y'all like this, I'll just do it this way too. And then I'll grab the loop. All right. So we have our loop. Let me make this a little bigger. It's kind of small, isn't it? There we go. Okay, so we have the matrix or a nested list. So it's showing the outer list is right here. And then you see each one of these arrows is pointing to another list for each index in the outer list. And then I'm making a loop. And I'm going to start looping over all of my items. So item becomes 1. And then it's going to move up and point to 2. And then point to 3. Then it's going to go back up to the outer loop and increment row to another list. So that's what row does. Row now moves to this one. And then it starts going over every single item there. And then this row is going to point to the last row. Boop, there it goes. And then it's going to print every single item in that list. And that's what happens. Is everybody clear on that, or clear-ish? At least you're starting to grasp the idea of using the indexing and just drilling down to a different dimension. So when I say matrix 1, 1, I'm at my matrix, and then this is the first index because 0 is always the first index. 1 is the second index. And then when I use a second one, I'm drilling into the second index of this inner list, which is the 500. Okay. Because we're just going to go up a dimension. So we're going to add a third dimension to our list. And so this one's not as pretty as the two-dimensional one. The two-dimensional one is pretty easy to kind of illustrate and show how neat it is. But when we look at three-dimensional list, now we have all these different colors of brackets, and that's just it's an extension I have to make the brackets different colors, so it's easy to see kind of what level you're in. But now what we're doing is we're making the three-dimensional list is this entire thing. So right here, and I have an example, it's limited to one line, it'd be hard to read, but you see the yellow closing bracket right there. And then that yellow closing bracket has how many items in it? Well, it has 3. It has 3 items. So if I were to run the length, oh goodness, I had it highlighted. Whoops. There we go. Len, my three-dimensional list. It's only 3 items. So the length of my three-dimensional list is only 3 items. Because if you look at the outer brackets, it only contains 3 of these pink brackets. So there's 3 items in that list. And then if I take a look at the first item in my three-dimensional list, which will be this right here, and you see the pink brackets enclosing it. If I were to say at the index of 0, it's also going to give me a 3 because there are 3 inner further drilled down lists. There's 3 items in that list. So 1, 2, 3. And so I can say, well, I can just keep going, right? So my three-dimensional list at the index of 0, 0 would be 0, 0. How many items are in there?
Three.
3. There's 3 items in there. And so if I want to access the first item in that listing right there, if I want to access the 1, I would have 3 zeros. And I run without length, of course, because I'm not running a length on a number. So if I want to access it, that's how you would get to that one singular data point right there, is by using 3. So I added a dimension, so I have to add a way to access the item in that, in that third dimension. So here, how would you return the value 24? So the 24 is way over here. We can see it. Okay. So how would I return that? Well, I can do at the index of 2, 1, 2. So let's see. My 3-dimensional list, the index of 2, well, you have 0,
7.
1, 2.
Oh.
And then the 1 is right here. That's the second one. And then the 2 index is the last item in that one. So it's 2, 1, 2. James, well, because we moved into 3 dimensions now. So, with 2 dimensions, you can think of the 2-dimensional like a spreadsheet, right? But the 3-dimensional list is kind of like a Rubik's Cube. So, we're adding another layer, right? So the overall list as a whole, it has 27 items. And if I want to access, if I want to take a look at this and break it down into individual objects, you could say each one of these layers, right? So if you take a look at the top layer of that Rubik's Cube, that would be a collection of these pink brackets right here. And each one of those is broken down into these 3 individual lines. And then each one of those individual lines has an inner pixel or square or cube. And that's how you would access each individual point. I have 27 items in my 3-dimensional list, and it's broken into rows, columns, and layers, if you will. So in the z-axis. So how do we loop through the data in that? We just need to add another layer to our nesting. So we just need to add another layer in our for loop. So here we have the outer loop is going to iterate over the layers one by one. So, each one of these layers is going to get run, and that outer loop is going to run 3 times. Oh, good question, Art. So it could be. In fact, it could be -1. That'll get you the same result. You can have -1 here too. Because 2 is the last item in the list, so it could be -1 if you want to use the last one. So the outer loop is going to iterate over the layers one by one. And then for each iteration of the outer loop, the middle loop iterates over every row in the layer, and it runs a total of 9 times. And then the innermost loop iterates over every item and for each iteration of the middle loop, so it runs a total of 27 times. So if you take a look here, that's how I name them for layer in my 3-dimensional list. And then for row and layer, and then for item and row, print the item. If I run that, that's what I get back. Every single item iterated over. It gets a little funky on Python Tutor, but I'm going to try and put it in there so y'all can visualize it as well. So I'm going to grab my three-dimensional list. Oh, it's so hard to scroll this right there. Can't see me. Then get this one. Okay, I think I have it. So visualize execution. Now it's 80 steps in this one. And so, well, yeah, told you it'd be a little messy, right? Because it's trying to point to all these different nested lists, right? And all these different layers. So remember the last time we had basically this portion right here as the entire thing. But now we have 3 layers. So these are the layers right here. This is layer 1, layer 2, and layer 3. And then each layer has a nested sublist. So it has 3 sublists, and each one of those sublists has 3 items. So it's just breaking down to that structure. So you can kind of see the structure broken down to go back to the main list. So it's going to run through, and here we have layer, right? Layer identified, this line connecting right here to a layer. So this whole thing is the layer. And then it goes into a row. So this is now the row in the layer, which is in the main list. And I'm going to start printing. So I'm going to go over and just iterate over each one. And then that middle loop is going to enter in, it's going to increment by 1. So it's going to finish printing, and then it's going to go back to line 4, and that row is going to go tick down to here. So that's what happened. Row just went down to this one, and then it runs 3 times. And then next time it iterates and gets the last one. And then that's done. So then the layer is going to pop to the next layer. And it's just going to repeat the process over and over again. And you're going to get each number printed out in the output.
Question.
Yeah.
So practical use for this, I mean, there's lots of examples of how to use it, but when you're actually typing out a program and you're putting this in, do you have to know where those places are to call on them, or are you calling to identify what's in that spot?
Yeah, you're going to know like the structure of your data. And when you're dealing with 3-dimensional data, you're typically going to be using libraries anyway. So this is more of an exercise just to see how it could be structured, to get you to kind of think, this little more abstract way. I'm not going to be there like going and trying to, access a certain data point inside of a multi-dimensional list to see what it is, typically using all that data as a whole, but it's just structured that way because it has to be. And so, and I don't want to get into big detail. I just want you to see how this list can be structured to form like a physical object, right? So, and that's really as far as we're going to go. We're going to stop at 3 dimensions. We're not going to go any further. We're not going to, start diving into how to, do something else other than maybe appending, extending. So just knowing how to access individual points of data is really all I want. And I'll show at the very end of the lesson, there's some practical, exercises for multi-dimensional lists. But really, this is meant just to give you a picture of how data can be structured and nested, because there's more than just lists. You can use dictionaries too. And you'll see in the further examples what I mean.
Thank you.
Yeah. So here, so any questions on just the overall like 3-dimensional list and how we're adding extra indexes to access that 3rd dimension in there? Okay, we can move on. So we can still use those list methods when we're dealing with nested lists here. So I'm going to redefine my matrix here on this cell. So now I have my matrix, that 500 has been removed. But you can still you can append things to an outer list. So in this case, I have my matrix and I have, my 3 indexes in my matrix. If I run append and put these in here, that'll work. And it'll give me a 4th index. It doesn't have to be, I've made it to where it's always a nice, square, format where I have 3 rows and 3 columns. But in this case, now I have, I have 3 columns and 4 rows, because I would just add another row down here. So it'd be the same thing as doing that and then getting my 400, 500, 600. So that's the same thing. Just this is all laid out flat because that's the output. You can use append or you can use extend if you have another list and you want to add it to your matrix. You can use extend, which will add items one at a time, or insert. You can find an index and insert data. You can do all the same operations. You just have to think about what dimension you're at. So if I wanted to just add one item to this row in my matrix, what would I type? So let's say I want to add the number 200 to that middle row. How could I do that?
My matrix dot append parentheses and then square bracket. And which row? Second row. So you go 1 in that square bracket, and then another square bracket, 400.
Like that?
Maybe.
Maybe. Does anybody agree?
Oh no, you'd have to go to, no, that's right. Yeah.
Okay. I'll run it and see what happens.
Oh, I might put it at the,
No, it says index error, list index out of range.
so you have to go to 3, index 3 in the second square bracket, and then another square bracket, 400.
So 1, 3, 400.
Again, maybe. I think so.
No, list index out of range.
Then I clearly don't know.
Okay. So here it looks like James says 1, 1, 400. So what would the whole command be, I guess? If I want to add an index to this one right here, and I want it to be the, like 200 or 400, just some random number, really doesn't matter. I can just say, how do I add 200 to the middle row? Like that. There we go.
Do you have to add another? No, you wouldn't have to add another dot append, would you, for the second bracket? No, you wouldn't have to do.
Mm-mm. So James, how would I use that combination there? That combination of numbers you have. It looks like you have some brackets. You have 1, 1, 400 or 1, 1, 200. I assume you mean.
So you're trying to add it after the 6, right?
Yep.
Okay, so then it would be. Would it be then 1 close bracket, then 0, 1, 2, 3 close bracket, and then 400 and close bracket?
So like, would I put that in append like this, or how would I do it?
Yes, my underscore matrix dot append, parentheses, open bracket, 1 close bracket, open bracket, 3, because it would be 0, 1, 2, 3, because you're trying to put after the 6.
Mhm.
close bracket, and then open bracket 400, close bracket, close parentheses.
Like that. And I get list index out of range still. Oh, we got some other answers in here. We got, okay, so now, so some of y'all are saying, no, don't put it in there. Put it right here. Like that. And looks like append 200 like that. I'll go ahead and do that. There it is. Yeah, it was any number. It doesn't have to be like 200. It could be any number, but yeah. That's how you do that. So y'all learned when you have a list, right? You use a dot append, right? Which when I do this, I'm still accessing a list. I'm just accessing this list. And then I'm appending a value to that list with this. So that's all I'm doing there. Let's take it a step further. Where am I? Over here. Okay. I want to access here. I want to append chicken to the row with 19, 20, 21. How do I do that? Okay, I have an answer here. Let's see. That's the wrong thing. So my three-dimensional list, 6 append, and I'll go ahead and make it a string for chicken. That way it doesn't yell at me. And let me go ahead and do my 3-dim list. List index out of range. Gosh. Okay. Okay. It looks like Amber has one and Miguel has one as well. Let's try that one. So Amber says my three-dimensional list, and then it says 2 and then 0 dot append chicken. There it is. And if you look at this, okay, let's take a look at how we do this, right? So remember, we have a three-dimensional list. So we're looking at the first layer is the entire list. And it has how many items? It has 3 items. So 1, 2, 3. It has those 3 items in there. So I want to get to the 19, 20, 21. Well, that's in the 3rd item or the 2 index. So that's where this first 2 comes from. Then inside of here, I want to access the first index, which would be 0. So this is the 0 index. That's where that 0 comes from. And that's the one I want to append. That's the basically the sub list I want to append chicken to. So you just do dot append chicken. And then that's where the chicken comes in. Cool. I like seeing thumbs up. Hopefully that cleared up things a little bit and kind of see how you can access the indexes. And then with looping, it's the same thing. You're just adding layers to loop over. So when you want to loop over items, you have to drill all the way down into that dimension to loop over every single one. So that's the most complex we're going to get. That's just a way to kind of see the multi-structured data. You'll see this a lot when you're developing. This is a very common, you know, whether it be list of lists or a list of dictionaries. Typically the second dimension is where you see a lot of your stuff. Sometimes you see stuff in the third dimension. It happens. So we left off here where we had my matrix append and we added this as a list. We want to replace rows and columns. We can just simply assign a new list to a row index. So if we go back to my matrix and we want to replace the 400, 500, 600 with 10, 11, 12, well, you can do that because you can change lists. Lists are mutable. So we can just go ahead and assign a new list to that row. If I ran that, oh, I had a 200 in there, didn't I? I kind of messed up my matrix. Let me go back and run this real quick, and I will get rid of that. Let me run that real quick. So boop, and then run that. Okay, now it'll run correctly. Now it looks right. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12. So I believe this is a holdout from previous lesson. Let me see. Okay, what's happening here? Let's see what's happening here. What did I do here? So I'm saying this is now I have a loop and then another nested loop, but it's a different type of loop. It's like I'm using a range loop and then I'm using enumerate. Okay, so all right, let's see what's happening here. So for I in range length my matrix. So when I'm talking my matrix, I'm talking about this product now. So for I in the range length my matrix, so but this is the first for loop, so there's only 4 items in my matrix right now, or at least this layer. So then I use a nested loop to enumerate each sublist. So I'm saying for index item and enumerate my matrix at the index of I. So this will increment up by 1. If index equals 1, I want to go ahead and redefine it as item times 100. So if I ran that, okay, so this is just multiplying. It's multiplying the middle number by 100 when it runs over that loop. And so this is a way to illustrate that we can use different types of loops. As long as we know how we're accessing the data, we can still use different types of loops to do nested loops if we want to. Any questions on this? This is really just list methods and list, manipulation on steroids, just using different dimensions. It's the same concept as a single dimension list, but we're just going into rows and columns, or even layers, rows and columns. So we're going to move into other nested data structures, but let's go ahead. It's already at 6:48, 6:50. Let's go ahead and take a 12-minute break and resume at 7, because I think we have this and then just a little bit left to do. So yeah, let's go ahead and take a break. Pause it. All right. Welcome back from the break, everybody. Before the break, we really went into these, multi-dimensional lists, and we talked about the different methods, and we looked at how we can loop over multi-dimensional lists. And this problem or this concept may be a bit hard to wrap your mind around, but I promise it will get easier to think about. There's several concepts in programming where you have to nest into different dimensions, not only with like, data structures like lists or dictionaries or anything, but functions themselves can like call themselves in their own definition and like get into what's called recursion. So there's a whole other concept. We're not going to go into recursion here, but you can Google it and see kind of what it's talking about. But we're going to move into some other nested data structures, which really it's just really nesting data structures that are different. Maybe having a list inside of a value of a dictionary, or a list that contains several dictionaries. You will see this out in the real world when you're developing. So it's good to have your mind wrapped around, at least get the introduction here. And of course, getting practice working with this stuff, this matches, those concepts we're trying to teach in this course, which is dealing with key values in dictionaries, changing lists, dealing with functions, working with string methods and changing those. So in this example here, this one is a pretty simple example. We already saw this actually, right? So we saw this English-French dictionary, and we had hello and bonjour, and then I did add another example of saying hello in French. We have salut in here. So we have we're redefining. So first, when we initially make this dictionary, we are saying, okay, this is my dictionary and this is my key and value. And we can see that it's a dictionary because it has the curly braces on the other side, and then it has the colon inside. So it has a string for the key. It has to be some sort of immutable data type for the key. And then we have our value, which can be any data type. And then we're going right into redefining what that value is by saying, okay, I want to call my English-French dictionary at the key of hello. And then I want to say, never mind, it's not just one word, it's actually two. So I want to make a list of words that could stand for hello. And then I want to have my English-French dictionary, which I can get rid of that because I think I was doing something with that. But now I want to access just one way to say hello. In this case, I want to access the second way to say hello. And so to do that, I need to first call my key of my dictionary. And I want to say, okay, I want to access this main list, but then I want to access only the second item in that list. That's where that, just same way we learned with multidimensional data structures, we're just adding a little more information to drill down into this list. So we're accessing a dictionary first, and then that list is part of the value. So if I ran that, I get back salut, because that's the at the index of 1 of this value. If I change that to 0, I'll get back bonjour. And so that's how you could access, and then what if there was a nested list in here? So what if we had other, and then we're going to apply to English-French dictionary, but what if I had some other nested lists in here? I would just start adding my layers to access those individual data points. But let's just take a look at this like little exercise we have. And so I have a dictionary here, and it looks like it's pretty complicated, right? We have a school dictionary here. And it looks like let's kind of break down how it's structured and see what's going on. This would be a very common example of seeing like some sort of JSON data structure or some sort of database structure of a directory of a school. This could very well be a good directory for a school. It has individual people. So we have this curly brace right here, this yellow one, and we go to the very bottom, we have the closing curly brace for that. And then it looks like we have a bunch of, so it's a dictionary because we have a key, and then we have a colon, and then a value, and that value is a completely different dictionary. So that's already, we're starting to nest our data structures in here. And not only that, we have a bunch of keys in that sub dictionary, and then some of the values are even further made into lists. So we have even further in there, we have more data structures. But if you take a look at how this data is organized, we have some sort of like person 1, 2, 3, 4, 5, right? We don't know who that is just by looking at the key, but if we access that with the value, we can get some more information. We can get the first name, last name, and some other information like is student, is teacher, looks like children is referencing other keys. And so, and that's how we have the question, having access to only parent info, how can you find out their children's names using Python without actually reading this data structure? So we can use Python to do that. We can access different data points inside these dictionaries by looking at how the data is structured first and then coming up with a way to write it. In that example, I have it written out right here. So we have, I want to first create a empty list called names. And then I want to loop through this dictionary. So, I want to say, okay, well, I'm trying to find if I have access to only a person, right? So if I know only the parent info, how can I find the children's names? Well, I can say, well, for child in school dictionary, and then I want to access the values of that key. So I have school dictionary, and then I know I'm looking at person 1, 2, 3, 4, 5. And then I can just go to the key of children, right? And so I have key of children. And then so it's going to loop over that. If it's a list, it's going to loop over that and then give me a append. So it's going to append the name of those children. And so in this case, I'm formatting a string and I'm saying, okay, well, school dictionary at the key of child and get the first name. And then get the last name. So I'm getting the first and last name of that child. And I'm using the parents' information to do that. Because what is child going to be? When I loop over this, right, I'm looping over a dictionary. What is child going to be every time I loop? Wait, am I looping over a dictionary or am I looping over a list? Let's start there. Dictionary.
Yeah.
Dictionary. So let's go ahead and do this. So let me run this code. I'm going to add a code block. I want to look it up. So dictionary, school dictionary, person, 1, 2, 3, 4, 5, children. It is a list. So I'm looping over a list. This right here is a list. And then I'm going to loop over each child. So basically what child becomes is person 94523. And then what it's doing is it's referencing school dictionary at that key and getting the first name. So if I run that, now I have the 3 children of person 1, 2, 3, 4, 5, which we can look at the list, and it's Jim Smith. So it's all Jim Smith's children. Yep. So how could we maybe find all children in the dictionary? So if we want to find all children in the dictionary and just get all the children's names.
Would you do a loop that identifies within the dictionary the key that's labeled child or children, and then a loop within that that looks for the list of children within each key that's children. That's as far as I got.
It gets pretty difficult, right? So, well, we know, like, okay, so we know there are children in here. We access them through this way, right? So we can say if v dot or v at the key of children. I think we can do this, right? So v at the key of children is does not equal in A. Because it looks like here somebody has children in A. Then we know we have children, and we can then say for child in school dictionary key children. We can do the same thing there. We can make a names here, so we can do names. And then we can append those names. We can just do the same thing here. Names that append, and it will be for child. Yep. Okay. Else continue, which it will still just do that anyway, but we'll do that. Does that work? Oh boy, do I didn't print names. Try that now. There it is. That's all the children looks like. If we take a look here, children, 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 children. Yep, looks like children there. But what if I
So
added,
that's only showing the parents of the children, right? Not the.
what's that? That just finds all the children. That's all I said, just finding the children, all the children. Yeah, it doesn't mean if they're students or anything. But you can see how you can develop all sorts of loops to find information, you know. In this case, we have a teacher, right? We have is teacher, and looks like they have a class, and who's in their class. You know, how can you find that out?
I see now, looking back on it. So the parents or teachers or whatever that's not a child would all have an NA. So I see where I messed up.
Yeah. Well, it may not be the case, right? You mean you could have a person that is a teacher and is also guardian, and they have children and also a class. So there's all sorts of things, you know, you could do. And Wayne, do you need me to paste what code?
Oh, that code that you just typed, I thought I'd put it in just and play with it.
Oh, okay. You talking about this one right here?
Yeah, the one you just typed, yeah.
Mm.
I can't type fast enough to get it all in time.
There you go.
Quick hint: if you open a Word doc and then you hit Windows key, Shift and S, you can take a screen snippet and then paste that over to a Word doc. Sounds complicated, but it's really fast and easy. And then you have the code to refer back to in your own time.
Then use Copilot or something to read the image and extract the text. Or I can just paste it into the chat. So here's one, says here's a teacher one, right? So for K key value in school dictionary items. If the is teacher true, then append. So Gertrude Brown is the teacher in there, which is right here. So this is just a quick example of how to kind of see how you can mess with a multi-structure, multi-dimensional data structure. You'll see a lot of data like this, a dictionary or JSON that is, up to millions of lines long with a bunch of data in it. And then how do you parse through that data? And that's the real ticket. So, so moving on, we're almost to the end of the lesson. We just have a couple of examples of this dimensional data, and then we can move into back, maybe to the exercises from yesterday and kind of continue those. I think most of you found that pretty valuable last night looking at that. We can go back to that. So let's say, for example, we have a seating chart for a theater and we need to update a reserved seat. So we have a seating chart broken down in our code. So each one of these is kind of an address, right? And they reserve seat F, row 2, seat 2. So let's, we take a look. We have row 1, 2, 3, and it looks like, or 1, 2, 3, either way you want to look at it, right? Row 2, seat 2. So that's, 1, 2, 3, 4. So row 2, seat 2, this F right there. Let's update it. Well, we can say seating chart at the index of 1, and then the index of 1 equals X. So if I have that there and I run that, now that one has been reserved and no one else can reserve that ticket. So you can see how this multi-dimensional seating, this list could be very useful for like sections of a stadium, and they have, a way to compute all of the seats and put them out graphically. You can use, these multi-dimensional arrays or Python lists to see that data. And so when you go on, I go to Cardinals games quite often, and I go on to the MLB app and look at tickets, and I'll try and find some good tickets, and they'll have them red or blue based on who has a reservation or who has the season tickets. And then I can't buy the red ones, but the blue ones I can buy. So it can be very useful. It could be a real world application. Okay, in this case, looks like we have some sales data. So this is kind of like a spreadsheet, right? So we have our first row is kind of like the title row. And then we want to add a new row for Charlie. We can then, have our new salesperson, Charlie, and we can just append to sales data, which, remember, sales data is this entire multi-dimensional list, and it has rows. I just want to append the last row on there. Also, it's there, so I can just say, append new salesperson, and then take a look. And if you take a look here, Charlie was appended at the bottom. If we want to add a new column, so we have, name, January, February, March. Well, how can I programmatically add a new column of data in there, and with some like initial values? Yep, Art, append always adds the end. So when you append, you're always adding something to the end of a list. Yep.
Well, that answers the question I was about to ask, if you can append a range. But
no, it's, this is, what this is doing now is, we're going to add a new column of data. So you're going to see something added to the end of each list. And what we're doing is, for I in range of length of sales data, you can insert by using the insert method. For a list, the insert method is how you would do that. Now, what happened here, what this did was it just put in a 0 at the end of every sublist. So for I in range of the length of the sales data, so I'm just getting a number, right? And so the length of sales data was 1, 2, 3, 4, right? So it's for I in range 4. Sales data at the index of I, so the first time this loops, it's going to grab this first row. And it's going to say sales data at the index of I append 0. So it appends a 0 at the end. And then it's going to go to next number. So I becomes 1. It's going to grab this one, append 0 at the end. Then it's going to do it again. And so it's kind of appending like an initial value, right? So you may have to go back and change this. But I wonder how we could maybe alter this, right? So let me go back and run this again. So we have the sales data. How could I do that, but maybe also append the month to the first row? Versus just putting a 0, right? So we're just putting a 0 at the end, right? How could I write this loop to append April to this row, but a 0 to the other rows?
Can you repeat that again, please?
So let's I ran this loop once, right? And when I ran it, it just appended a 0 at the end of every row. But how could I write this logic? And I've reset it to where now we're back to this state for it. How can I write this logic, or maybe add additional logic to where when I run this loop, I won't append a 0 to this, but I'll actually append April, so APR. But to the other ones, I will append a 0.
Could you do if the length of sales data is 3, then append April?
Well, it looks like the length of all of them is so 1, 2, 3, 4. So each one is 4, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, right? It's before the zeros, right? So I wish let me see if I can clear just this one. I think I can.
0, 1, 2. It said before, yeah, not 3.
How do I just clear this cell? Clear cell outputs. There we go. There we go. Okay. So we're looking at this one here, right?
Yeah. So if length of sales data equals, it's not going to equal 4 because there won't be 4.
No. Would sales data at 04.append April work on line 5 instead of chaining code? I mean, we could do a single like argument before doing a loop, but I would say let's just go ahead and just use a loop so we don't have to think about it, right? So we may have to hard code our month in there, or maybe we could even have like a separate list of all the months, right? And then we can see, which ones are in there, which ones are not. So is there a library we can import the ID months and replace that index with the proper months, or maybe define months? Yeah, we can maybe define months, or we can just work with April, right? So we know we want to append April. We could make it as complex as we want, right? But I would say let's take a look at, well, we kind of know that the last index of each list, right? This is a string, but the rest are numbers, because it looks like each one of these is the person's sales numbers, right? So sales numbers. So if we know, so if maybe we could say if sales data I -1, we could say type. So type. We can then say April. Else. Zero. Can we do that maybe?
So you're saying if the type of data at -1, so the last column, is a string,
Mm-hmm.
then we're going to append April. If it's not a string, we're pending to the front. What?
We're not pending to the front. We're still pending to the end.
Oh, we're adding a 0 instead of adding April. I see. Okay.
So there we go. So what it did was it looked at this index of each row and said, what type of data is that? Well, the first row, it's a string. So I want to append April after that. The rest of the time, it was an integer, int.
Mm.
So that's a way you can do it. That cleaned up and made it's a little more complex, but it kind of made things a little easier for you. You don't have to go back into your data and change something, right?
Can you do it the opposite? If it's instead of it equals string, can you do it if it doesn't equal an integer?
Yeah, you can do that too. You sure can. So you can say like that.
Yep.
Yep. So let me run this one again to get it back, and then I'll run that. Same result. Yep. So there's using the does not equal, that could work too. All right, cool. So that's really basically the lesson. This is a little bit about practical application of multi-dimensional lists. So like, the two-dimensional lists, good for data tables, images, games, and more. And then the three-dimensional lists, really, they're kind of used more in geospatial, data science, and machine learning applications. If you're interested in like machine learning and stuff, you can take a look at these libraries here. You have NumPy and Pandas. Pandas is really cool because you can work with all sorts of cool data sets. Like it turns things into data frames that are easy to work with. And they're really complicated data frames. And then NumPy, is good for working with those multi-dimensional data sets as well. So I'm not going to get into a lot, but in Code Platoon, the course itself, they actually go into PyTorch, which is a machine learning library for Python. You have that in TensorFlow, and those two are meant for training machine learning models for image recognition or any other types of machine learning applications. So it does get a lot more complicated, and these libraries really help you work with lots of big data where you're not looking at individual pieces of data, you're looking at data structures. It's pretty cool stuff. I take a look at it. You can go to all the resources like RealPython has some good stuff on it. And you can also find YouTube series on a lot of this stuff as well. And how much does the course get into machine learning? It doesn't get into a lot. You do actually, I think you get into training on like a small model or something, but it's really surface level stuff. Like it gives you good concepts because it's important to know this stuff. You're going to see it more and more in various code bases. So understanding how machine learning works and then even AI, how these models are trained and the types of data it's trained on, it's pretty cool how you can turn basically any data type or any kind of, um, images and, speech patterns. So like when you're analyzing speech patterns, you can find, you can train models to understand speech patterns and kind of listen for very nuanced like signatures, which will then, cause if you have a application that's recording speech, you can kind of recognize inflections and stuff like that, and then it'll flag based on whatever you're looking for. It gets really cool. So yeah, that's the end of the lecture though. So that's hopefully you learned quite a bit learning about these multidimensional data structures, and of course everything that's been leading up to this point. Hopefully you feel a little more comfortable with the application. with the, I don't want to say the, the impending, meeting you have with Guillermo, but yeah, I hope just going over the stuff and kind of, it demystifies it a bit. And now that we've seen all the data structures and how to work with it, we're going to get a lot more practice. We still have another week after tonight, another 3 days, and where we're just going to be looking at exercises. And so this is the time, because we're getting close to crunch time. This is the time to start looking at finishing up part 2, and then moving into the assessment with Guillermo. So I think we probably do have some time for the employee data. I know you asked about that yesterday. In fact, we can probably go over that now. Let me go back to it. I think it was in this one, right? Let me see what we have here. Yeah, we can probably put it right here. Okay, so you're a new programming company. Your CFO needs some data regarding all the employees. Your CFO needs to know number of employees per job title, the average salary for that job title within the company, the average bonus that job title receives within the company, and the average total compensation for that job title. Okay. You're given an array of objects that represents all the employees. You need to parse through all the employee data and return an array of objects that represents each job title and the corresponding compensation data, including title, total employees, average salary, bonus, and average total compensation. Okay. So the solution is going to look something like this. So, okay. All right. So how can we approach this? We want to get the number of employees per job title. So you just want to get basically, okay, so we need to get the title and total employees for each one. And then we want to average some stuff. Okay. So it looks like we're averaging the salary, the average bonus, and then we're taking the two and then average them based on which ones they are. Okay. Oh, imposter syndrome is not a millennial thing. For sure. I still have imposter syndrome to this day. I'm like, they hired me to do this. I don't even know what I'm doing. So, okay. So, Amber, were you like completely stuck, or did you try some approaches? Did you have like an attempt that you wanted to kind of put in here and see what we had? You're pretty much overwhelmed. Okay. All right. So let's see. How can we do this? Well, looks like this is how we want to structure our data, and we have that done. Okay. So we could probably, we're
going to want to run some loops here to find who equals those positions.
okay. So you want to start with some loops, maybe see what we have. So in fact, we may be able to solve this with just 1 or 2 loops. We don't want to loop over it all sorts of times, but if we want to come up with an initial solution, right, to brute force this, see what we can find, it's 100% acceptable to come up with an interim solution that works, but it's very You know, it's not maybe exactly dry like we showed yesterday, where they had that repeating code, you know, and I was like, oh wait, we can probably extract this function or maybe move this if else somewhere else where we don't have to repeat all this code. You know, when you're trying to solve a problem, you know, especially in front of somebody, you know, whether it be for an interview or for this, you know, coding application, sometimes you just want to talk through it and then just, you know, come up with an idea and say, maybe this will work, you know, or, you know, is there any limitations to my data that I have? And doesn't look like it. Looks like it's all pretty well structured. So yeah, we think about it, like there's some things we don't need, right? We don't really care about their names. Looks like we're not using their names in the answer at all, so we don't need that, but we definitely need the title, the salary, and bonus. We need those three. So this is kind of like filler data, right? And we have employees and we have their name, but we don't need that for our purposes. So we don't have to worry about looking at name. Okay.
Can you scroll back up to the word problem?
Yeah.
Thanks. I want to capture that. I keep trying to look back and forth here.
Oh, so it's in if you go to lesson 4, it's a Replit. So you can look at it that way too.
Okay.
Yeah.
All right.
I just moved it here because I can't use Replit anymore because I'm reached my limit as well. So I can't do
I have too. So I'm trying to. All right. So we need to capture what data? We need to figure out. Job title and how much that title makes. Okay. We need to figure out why is it title in there twice? Job title and corresponding compensation data, including title.
Yeah, that's kind of a typo. It's really just job title. So what we're looking for is
job title, compensation, total employees, average salary, average bonus, and average total comp.
Yeah, we're looking for this basically.
Okay. And so we've already got it kind of laid out.
So define title, salary, and bonus. Okay. So maybe we can do let's start with title. So what if we say all titles equals set? Go there first. And then, because we know, like, we just want to get unique titles. So if we see multiple ones, then it won't add anything. We'll just, you know, we can still add it to it, but we'll only see the, you know, unique titles. So we can get all the titles. Because that, if we have the titles, then we can structure our object, then our list of dictionaries. Because that's what's really unique about it, right? So we have, you know, a unique title, because total employees may have the same key and value pair like this, but this will always be a very unique key and value pair, if you will. So we can say our all titles is set. So we want to get a set first. And then how else can we? So we have that. You want to define salary and bonus. Okay. So it looks like we'll have to do some calculation to get the average total compensation. So that's something we're going to have to derive with the other data.
Is it asking for the compensation split and average total?
Yeah, so it's looking for the average salary for each job and also the average bonus. Yep.
But not so okay, because it says for each job title and the corresponding compensation data, which would indicate the split of salary and bonus.
Yep. And the
and
average.
Then an average.
And the average, yep. Yep. So we know we probably want to get the all titles. Okay, we can do that. And then we need to calculate for each one. So let's go with so let's get our all titles so we can just loop over the object first. So we can loop over the employee data. So employee data is a list, right? So item is going to be a dictionary. So if item title, when you put in quotes, it's not in all titles. All titles. Actually, we don't have to do that. We can just say, we don't have to ask if it's in there. We say all titles dot add item title. So let's just see if that works first, just to kind of, and then I'll do this as well. And I'll comment this one out so we can use it later. So let's just see if we get back this and just see what we print. All titles. Okay, so it looks like we do get the titles back. We have 3 titles, which is exactly what the answer has. So we have a set, right? So what we did was we create a set. So we didn't have to worry about doing any checking of if it's already in there, because we can just add them all and it will just give us back what we need. Right?
So when you're trying to lay this out,
Mm-hmm.
can we just keep basically looping for the different data set? And in some of it, we're actually going to have to do some computation, but that way, when you print the whole thing, it'll print it out in columns like this. So designer would be index 0. So we want all of the data pertaining to designer to print below that. The
There's no
compensation.
indexes. There's no indexes with sets.
Right. They're like, okay, that position. So when it prints, it'll print the same. It'll print the data for designer below designer in that order, and developer.
Or maybe you can add that to an object to, or maybe even another function. Maybe we can get that. Let me answer some of these questions up here. So James asked, what is the equals set doing? So remember, I want to create an empty set that I can add stuff to, but you can't create an empty set with the curly braces because that will give you a dictionary. So this is the only way to create empty set, is by doing the set method. And so that's all I'm doing, is just creating an empty set. And then the add method is only for sets. So that's kind of like append, but remember, append is append something to a very specific position, the end, right? But adding, you're just adding an item to a set, because sets are unordered. So we're just adding an item. So we're adding that. Okay. So at least we know we can get at least all titles into a set, and we have that. And so now we know all of the titles. So what if we looped over the set, and then with that use that information to grab the the salary information from any of these dictionaries that have this information, and then do
So,
calculations that way.
like if title equals product manager, and then pull the salary.
So yeah, so we loop over the titles. So for item in all titles, because now we know it's all there. So we're kind of using multiple loops, which is fine. I mean, we could probably figure this out with one loop, but let's go ahead and just do another one because, well, we can. And we have a very powerful computer. We can do whatever we want, right? So for item in all titles, and then we can use a loop again over the employee data. So for, let's say, for entry in employee data, employee data. If, let's see, so for item in all titles, if entry title equals item, then we can use that to append values, right? So then we can use that to get the salary information. So we'll, basically if if I'm on project manager and if my entry title equals product manager, then I want to grab the salary and bonus and put those into a holding, like a salary list or something that I can then do a calculation on, or maybe even like a dictionary. That way I can hold that. So let's see. So let's say we have our salary, right? So salary. So job salary info. And then our job bonus. Again, we're just trying to categorize data so we can grab it and do something else with it. And so if that entry equals type item, then I want to say job salary dot append, and I want to say it's entry salary. Is that what it is? Yep, and then bonus. And then when that loop is done, you too, Rob. Thanks for attending. So when that one is done, so I'm going to have everything for that job in my list. I can then just grab an average, right? So I can get the average job salary. So average equals average. Is it average? What is it? It's I can get the sum. I can't remember if it's there or not. Let me see. there was no average. I can't remember if there was or wasn't.
Is it not just AVG parentheses?
I
No?
couldn't. I don't think it is.
What about mean parentheses?
What are all the list methods? It's like part of like a different library, like statistics.mean.
Do you have to call in the math?
You have to pull in, yeah, either math or the statistics library. I don't want to do that. Let's do it. Let's keep it vanilla.
You could also do a count on the number of those titles, and then when you get the total divided by the number of titles.
Average the length of job salary, right? It's the sum of the job salary, not bonus salary, divided by the length. Len. Is that right? I think that's
Why
right.
would it be length of job salary? Wouldn't that just count the characters in the salary?
We wouldn't count the salary is a number.
Or
So job salary is a list. So if you have the sum of all of them, you divide it by how many there are, that gives you the average, right?
oh, it's of the length of the list. Okay, I understand now.
And then average job bonus equals sum job bonus and bonus here. Print. I'm going to just do a little check of how this calculation is going, right? So print, let's say item averages salary. Bonuses.
You missing a quote in there?
I put one by accident. There we go. There we go. And then I gotta close my quote there. There we go. Okay, so it says designer averages salaries 82,250. Designer 82,250. So that's good. And then we have this weird one, right? 127,33333. So it's close to it. And then we have 101, 101.
Now we could crop that and round it or whatever to.
Yeah, we'll have to do rounding or something, or just get the, yeah, we'll try to round it and then just call it a day. Yep. All right. Everyone follow along so far?
Sort of.
So we have that, and we can then, I mean, I think we need to probably start building our solution and then building out the object, because we already have the title, we have the average salary, average bonus, kind of, and we need to get the employees count as well. So maybe we can also get the we couldn't do the count here because we'd have to do the count here, because we're looping over the salary. Yeah, so we could actually add another. This one here is employee count equals 0. And then we can say print. The num of employees let's make it an F string so we can inject count or employee count. So let's say number of item employees. And then oh my gosh, these pop-ups. Employee count plus equals 1. Okay, that hopefully that works. Let's see. Okay, so number of Desire employees 2, number of developer employees 3, number of project manager employees 2. That should be correct. Y'all see how I did that?
I saw how you did it. I didn't fully understand it.
So remember, I'm looping over the set I made, and then I'm using that to access the employee data only at the one I'm on in the set. So when I start, I'm going over designers, and I'm saying, okay, if the job title of that entry is designer, I want to do stuff, and I want to increment my employee count by 1 because I found one, and I want to go ahead and append their salary and bonus to their respective empty lists, so I can then do my after that is done, I can then get the average job salary and bonus, and then I'm just printing everything else out. So I'm counting the employees, I'm getting the salary and bonus, and then yeah, I'm done. In fact, I can then actually do this. Now becomes employee count. This does too, because that's the length of the list as well. It should be. I don't think these are going to change yet. So employee count, I can use that for my averages instead of the length. So I have that, and then the last is the average total compensation. So that's everything divided by the employee count, right? So to get the average total comp equals some job salary plus some job bonus divided by employee count.
Let's go ahead and round while we're at it so we clean up our data, make it nice and pretty.
Yeah. Okay. And that is here, right? So round. There we go. don't think I have to, I'm not doing any places, right? So do I need, I don't think I need to put anything else, do I? End digits, none, okay. I don't think that's right. Is it? No. It's too high. So, oh, wait. It's, this isn't right. It's too high. So the
Because
average
it's
total
not taking the
compensation,
average
what's,
by position. It's not, is it doing the whole employee count, 9 or what, if it's 7 employees, or is it just doing it
oh,
by
yeah.
designer
So it's
employees?
so it's getting the average total compensation. So it's just adding for each one, it's adding it. And then, so you're getting the total of both the bonus and salary. And then you're dividing it by the number of employees, right? But
But is it,
I'm summing everything together.
which you could do as long as you divide by the correct number of employees. So it should be divided by 7 employees instead of, is it calculating this for each like designers or
Yes,
developers?
should be. Yeah. I'm doing this wrong. I just have to figure out what I'm doing wrong here. So I know it's a big mess of code, right? But we're getting to our figures, and we just got to turn it into that format, right? So so average total compensation, again, the total compensation is for that job title. So I was thinking you would add salary and bonus together. So I was just adding the sum of the two lists together. So the sum of job salary and the sum of job bonus. And dividing it by the employee count. Actually, what I'm doing right now is I'm doing, oh, I see what I'm doing wrong. I need to enclose this in parentheses. I think that's what I need to do. Because that way that gets calculated first. Maybe. There we go. Okay, yeah. 119,750, 119,750. Okay. So what I did, remember when Python does the math, I didn't have the parentheses surrounding this. So it was doing this first and then giving me the sum plus that. So it was a way higher number because it was adding all the job salaries together and giving me that. So okay. So in this case, what it was doing was it was forcing the addition first, then do the division of the employees. So I was just adding the extra parentheses around that. Okay.
Oh, one little character.
Yep. One little character. And again, this probably isn't the most efficient method, but it's a method to get it to work. And that's, as long as you're able to follow the logic, we could probably take a lot of this and turn it into other sub functions. So we would call the functions on that instead of having to write it all out for everything. But so now we need to take, now I think we have everything, right? We have all these. And so now we can make our result item here. Not here. We want to put it outside the for loop. So we want to make a result and it equals an empty list. And we want to create an object or a not object, a dictionary with all of these things in there. So we can say, so we can create our empty dictionary here. So we can call this job data equals empty dictionary. And then at the end of the loop, after we have our employee count, we have our title, and we have the other three, we can then say, okay, well, let's do job data title equals item. Job data total employees equals employee count. And then average salary average bonus average total comp. I don't know why it's AVT. Total comp's typo in the exercise, but we'll keep it. And then this is going to equal AVG, job salary, AVG, bonus, AVG, total comp. And then we will do result append job data. Okay, so we can get rid of these. So again, it's a long, like lots of lines, you know, it's not the best, but it's a good first hack at getting it. Hopefully it works. So we can then see what we get back. We can print it so we can actually see what the result is. And then we can compare it to the exercise. So none. Uh-oh, we did something wrong. Okay. Yes, I know what we did wrong. Job data, result append job data. Okay. What did we do wrong? Let's figure that out. Okay. We know that was there. Result is not in a loop right now.
Doesn't have anything to do with you calling it average total comp up top and then AVT total comp down below, does it? No, it doesn't, because it's AVG in the equal.
Well, because their thing has an AVT, so I'm making it that way.
Gotcha.
So job data. Well, let's go ahead and print. Let's just make sure we can print job data here. Oh, it's printing it. It has it. Result append. Oh, I know why. No, result append. I should do it in the loop. Job data. And then, oh, yeah, return, right? I need to return everything. So that's why. Return result. I didn't return. There we go. A list of, yep. So now we can do this one. And that one. False. Even though I think we had everything right. I can always print it too, just to be sure. Title, designer, total employees, 2. I may have something wrong with my average salary, 8250, 7750, AVT total comp 90,000, AVT total comp 90,000, developer, to employees 127,333, 13,140,333. Product manager, total employees 101, 18,750, and 119,750. I don't know. It's should be true. Looks like it matches. So I would call that it works. So hopefully everyone saw that. And yep, have a good one. Amber, did you see that? Like, it's a lot of steps. That's a lot of steps and a lot of things to figure out. And would take quite a bit. But even though it's not the best practice, you can still just make a bunch of variables, empty holding lists for your things as you're doing them. It helps you kind of see how the data is flowing back and forth. And we're putting a bunch of stuff in here, and that's we probably want to extract some of this to a different function or something. But right now we're just trying to really see how the data flows and how we change it and how we change the form. So hopefully just watching that whole process at least gave you it helped you kind of see how you can tackle a problem like that. I say we go back to the exercise we had here. So if y'all remember from last time, yeah, there were a lot of steps, and there's a lot of steps in this one too, right? So we have this coordinate, and we remember yesterday we realized, oh, we have some messed up data in here. We got some spaces up in these, and we have to make sure we get rid of those spaces. So we had to remember our string methods, and we stripped off the coordinate right away, so we can then work with it. And then and I think this was the example of the bad code, right? We had the good code, which moved some of this data around, like outside of this if statement. So we only had to call this once versus twice. But in the end result, like, we had nice, clean, organized coordinates. And so that was our first step. But now we have another step, and it says using those coordinate results. So we have our coordinate results right there. So formatted chords, we can use those down here. Combine the adjacent latitudes and longitudes into tuple coordinate pairs. So the result should look like this. So we have our list of coordinates, and now it's basically just grabbing the ones that are adjacent to each other. If you notice, is organized that way: southwest, southwest, northwest, southwest. So they're all already pairs. They're just not totally identified, and we need to somehow put them together. How can we do that? And it says save the resulting list into a new list. So, okay, so we know we need to make a new list. So we can say paired chords equals a new list. So we know we're probably going to start throwing stuff into a new list called paired coordinates. So what can we do to try and put all these together? And we know they're in order, so they are in order. So we can just basically grab the first two, then the second two, and so on and so forth. How can we do that? What should we use? Slice with a step. So slice the slice what? String, or the not string, the list. How about a loop? It says it wants tuples, right? So it says it wants, okay, so tuple coordinate pair. So this right here is a tuple. And so maybe we can do like, well, if we know we're gonna get basically every two and put them together, maybe we can still just loop over the list. We probably only need to loop over it once. And we can say, okay, so for chord in pair, what's it called? Chord, just formatted chords. So in formatted chords. Okay. And then this will be my final answer. So I'll have all the coordinates in it. So I don't want to put anything into there. So let's see here. I probably need to have almost another place to put them. So it wants it in a tuple. So if I can do like maybe single pair equals tuple like that, and then say, okay, so for chord and formatted chord. So I can then, maybe I can like maybe append something to the single pair and then check the length. And so maybe like check the length of my single pair, and if the length is, well, if it's 0, then I know I have nothing in there, so I'm at my first coordinate. But if the length is 1, then I need to add the other coordinate and then move them to paired chords and just kind of do that whole process. So if the length of single pair is 1, then I will add the other one to that single pair to get my other coordinate, and then I'll move it to paired coordinates. And then I'll just clear out. So maybe I can just clear out single pair back to it being empty to start the process over again. Do you think that would work? Okay, so let's say, so let's see here. So if single pair, oh, length, new length, so wrap it with len. If length single pair equals 0, well, let's say it's equals 1. Let's do it. If it's 1, then single pair dot append chord, single pair dot append chord, and then paired chords dot append single pair, if not wingle, single pair. Okay, and then I can then maybe clear out, or like, so single pair equals tuple, back to an empty tuple. And then else, so if it's not 1, it'll be 0, because we're going to clear it out if it hits 1, so we'll never see 2. So else single pair dot append chord. Okay, shall follow that logic? So I made my final answer, which is the empty list, because I want a list of tuples. And then I'm making a tuple with my single pair. So it's an empty tuple. And then I'm saying, okay, so for coordinate and formatted chords, if the length of my single pair is 1, so if this already has one of my coordinates in it, I want to append my other one, and then append that whole tuple, the pair that I just created. Now I have 2 in there after I do this. I want to append both to paired chords and then clear out single pair so it's back to an empty tuple. Otherwise, I just want to append it and then go back through the loop again. Anybody see any issues with this code as written? And are there any clues to maybe I'm making a big mistake. If I were to run this, am I going to get an error? Am I making a mistake and only asking for your input? Well, I think I'm probably going to get an error. Can anybody tell me why I would probably get an error? There we go. Yep. You can't append to tuples, right? So tuples are immutable. So once I make a tuple, if I make an empty tuple, then I mean that's it. It's an empty tuple. I can't add anything to it. I have to totally redefine it. So maybe I need to make single pair a list. And then, oh look, that append turned green, right? So remember it was a tuple before. So if I do Command Z, right? See how that append turned white? Because I can't do that. And Python's already telling me like, whoa, you can't do that. So I'm going to do a list. And then it all of a sudden pops in, right? And so what I need to do then is when I make this single pair, so the rest of the logic should work, right? So if it's one, I'm going to append it, and then I'm going to move that. But before I move it, I need to then cast it to a tuple. So I can say tuple pair equals tuple single pair. Now I'm casting it to a tuple. I can then send up my tuple pair, and then I can just make single pair back to an empty list at that point. And so now when I go through, if the length of single pair is already 1, so if there's already a coordinate in there, I'm going to append the next one, and then now I'll have 2 coordinates. I'll have a coordinate pair. I'll cast that to a tuple, so it'll become a tuple pair, and then I'm going to append that tuple to my paired coordinates. So I'm appending there, and then I'm resetting my single pair back to a list, and then it's going to go back. It's going to check, and it's going to see that it's 0, so it's going to hit the else statement, append it, go back up, see that it's 1, and just keep going through that loop over and over and over again. So now, if I go ahead and take a look at paired chords, and I run it, I get back a list of paired coordinates. And you can take a look here at the first 2. And there's the first 2 in a neat little pair. All of them are neat little pairs. Have a good one, Wayne.
Okay.
So that one got done. So it looks like we have the format we wanted. We wanted a list of tuple pairs and save the resulting list into a new list, which I did. I called it paired chords. So now I have paired coordinates. But we're not done. We have another exercise. So using that list of tuple coordinate pairs, save each one into a dictionary with keys formatted like so. We have location 1, and we have a coordinate pair, location 2, all the way down through location whatever. So it was called, again, paired chords. Keep that handy. Okay, so we have paired chords. All right. So we did that. Gave ourselves a pat on the back. celebrated a little bit. We got through that coding exercise. Move on to the next one. So how can we approach this one? So it looks like we have a dictionary with keys. So we know we want the result to be a dictionary. So we could start there by making a variable of an empty dictionary. So we can say result equals, and let's use the dictionary method. Why not? So the dictionary method, we go ahead and make an empty dictionary. Okay. And now we need to do something with all the data. Remember, the paired coordinates is a list of tuples. And all we need to do, looks like all we need to do is put that each tuple pair into a new key. And just, go down the list. So what tool will we use to do that? Okay, we can use a range loop using length. Yep, we can. So we can say for I in range len paired chords. Okay, we can just go ahead and get rid of that. We don't need that anymore. Okay. Then what? What do we put under the indentation? So now we're going to loop over. We're going to have a range up to the length of paired coordinates. And what do we do next? You're saying result I. So result I equals f string something. So result I equals something. Okay. So what are we getting at with result I? What is that? The element. What is result?
Or I guess I'm just trying to create a key value pair with it.
Yep. Yeah, you're trying to create a key value pair. So remember, whenever you're adding to a dictionary, right, you can just create a new key out of thin air, right? And
Yeah.
you'll get put into the dictionary. So what key do we want to create? Do we want to use I as the key? In our problem, it says it looks like it's going to be a string key, and it's going to say location 1 or location 2 and on down the line. So I think you're on the right track with using I. You want an index, right? So
Right.
So what if we just put an F string right in here and then do location I?
Ooh, that makes sense.
And so then we can say that equals paired chords at the index of I. And then let's see what we get back. It'll be almost perfect, I think. almost perfect. What's the problem that you see?
The location 0.
Yeah, we don't want location 0. We want to start with
So
location 1.
could you do I+1? Would that fix it?
Sure would. Look at that. Yep, that's it. Too easy, right?
Sure.
But this kind of shows you, this gives you a little further example, like, wow, I can actually use F strings and, my string interpolation inside of a key, like when I'm making it. Yeah, you
I
can.
just, yeah, I had the idea that I would need an S string. I just didn't know where to put it.
Yep. So you just do that way. You have a location, and then you just use that incrementing index in your range loop and just inject that right in there. And then it'll give you a nice unique key for every single location. Cool. So there's a result. And now we have our last stretch goal. So there are a few repeating coordinate pairs in there. We want to remove them from our dictionary. I don't know where they are. I know I put a couple in there. So we have to find the ones that are repeating without knowing where they are, but we will see it if we do something with it. And so this one here, this kind of ties into our dictionary lesson. I think I have, counting objects or counting items in a dictionary. So, yeah, so let's see if we can get there. So what's cool about our data right now is that we have a dictionary. It has unique keys because it's in the form of a string, and those are immutable data types. But we also have tuples, and the tuples are the values, and those are also immutable data types. And so what we can do then is we can loop over this, and we can loop over this dictionary, and then basically make a new dictionary and turn this into a key. And then with the original loop, check to see if this key is already in the new dictionary. If it isn't, add it with the count of 1. And if it already does exist, then we know that we have some repeating, one. We can figure out which ones are repeating at that point. That's one way to figure out how we can see the repeating data. And so what we could also do is we can get a set of all the values, and then it'll automatically remove all of the repeating ones. We can do that too. So for example, we can say like we can figure out how many we have that are repeating, right? So we can say len, if we can do it, let's break it up. Let's just say my set equals set, or let's do yeah, set, and then it would be result dot values, and then we can run len my set. Let's see what we get back. So we have 200. Oh, I wonder if let me do a len of my values first, just make sure. No, I do have 200. I wonder if I changed it. I may not anymore. No, I could have sworn I definitely had repeating ones in here. So we have 200 results. Let's go ahead and create that counting thing and see if we have anything that's repeating. Using the set should have told me I had something that wasn't repeating. Let's see. So result counts equals dictionary for A, comma B, and result dot items. Let's do a dot items. If see if so we're looking for result counts dot result counts let's see if result counts equals or no if it's if v in result counts dot keys result count b 1 else result counts b equals 0 or no equals 1. I wonder if I don't have any repeating. I wonder if I reverted that and got rid of the repeating ones. Yeah, I don't have any repeating ones. Okay, yeah, nope, I don't have any repeating ones. So yeah, I must have changed that.
Did you say something about dictionaries can't have repeating? So when it was because it's a dictionary, it's automatically removed the duplicates?
No, so what we did was we had tuples, right? So we had just a list of tuples, and those could have repeated. And then what we did was we just put each tuple into a unique key. And so you could have repeating values. I could have had several repeating values in here. I wonder if I removed them before and I didn't mean to. So I'm actually like, I need to add them back in. And then yeah, and so then all I did was just run a count on the items in my dictionary. So did y'all see what I was doing here with this? So I started with a empty dictionary called result counts, and then I looped over my result items. So key is the location and the V is the value. And I really didn't care about the key. I didn't even use it really. So I could have said for V in result values, that would have worked as well.
Where was the duplicate supposed to be? Was it in the key or was it in
it would have been duplicate coordinates. So
Gotcha.
like duplicate coordinate pairs, and I must have I must have removed them when I revised this course and I didn't realize it. So you asked Amber, if you did dot items, would that work, or do we need a dictionary? Yeah, it is. It's like the character count challenge. It's exactly the same thing. You're just using the count coordinates. Yep. So result dot values. If the values and result counts dot keys, then I'm gonna increment it because it already exists in that dictionary. I'm gonna increment it by 1. Otherwise, it's not in there, and I need to establish it as a new dictionary item equal to 1. So we found it 1 time so far, and that just loops through and gives you. But looks like I have full on 200 locations, and looking at that, the length of my result counts is going to be 200 as well. Yeah, so it's 200. So it must have already been removed. So yeah. Any questions on any of the stuff for tonight? Let me go back to the advanced data structures. If you notice, there's no more exercises. So, really need to start focusing on that part 2 challenges, the 3 exercises, getting your YouTube video done, and then start chatting with Guillermo and set up a date that you want to try the live challenge with him. I recommend getting that part 2 done as soon as possible. So this weekend, if you can swing it, getting it done and scheduling for next week during the week sometime, that will only help you in case you do you don't quite meet the standard that he wants. It gives you time to study and reschedule another time, and that's really what he wants. So if you're feel like you're 75% ready and you can finish those challenges, go ahead and knock those out, and that way you have time to schedule, and at least because you're allowed to go interview with him a couple times. And so if you just don't quite meet the mark, and you can try again, at least you kind of know what questions he's asking and you can prepare yourself for that. So yeah, so we can call the end because I don't really have much time for that, but I can help out anybody who needs anything tech wise. I can still help out. So I'll go ahead and stop the recording now and we can go through that.
So